Hello. So I did not manage to test to see if I can record things. I think I can. I think I am. So I don't know if anyone's here. All right, somebody's here. Good. I'm not all alone. Hopefully this is recording. We'll see. I need to... Yeah. Sorry. I'm new to this. I'm trying to share a particular application. There we go. Okay. So despite us saying that we're going to do things in C, I'm actually going to do it in Java today. Not that it matters. So we're going to talk about unit testing. So last time we looked at testing parameters into functions and making sure that we did all the things we could think of that were wrong, and make sure that we handle those properly. Unit testing is a formal way of making sure that we do those things, that we actually exercise those tests. So we pass in a bunch of bad data and make sure we return the right result. So let's make a simple function here. So I've got my sum function. I'm going to make it static just for simplicity. So it's a static sum function. It takes a bunch of an array of ints and it will sum them. Actually, I can be smarter than that. I can do that. So it takes a number of ints. It's a shorthand for an array. So var args. And I always make my parameters final, so you can't change them. So I'm going to take all these integers and add them up. So the first thing we need to do is, well, we'll come back to this, but the first thing we need to do is think what's wrong, what can go wrong. But we're actually going to skip over to the test for a second. Let's call it sum. So this is JUnit. It's similar. It's the sort of the first of the XUnit family. So depending on what language you are, there's probably a unit testing framework for it, and it's probably based on what we call XUnit, which just means it follows a general set of patterns for having functions and working in a certain way. Obviously, the way we do it in Java is going to be different than C++, is going to be different than C#, going to be different than Python, going to be different than JavaScript, going to be different than Swift, but they're all the same kind of testing if you're using XUnit. So we want to think of, before we even start writing code in the sum function here, or sum method, we want to think of what could go wrong and write tests for that. So, and what could go right. So we want to do an assertion. So the expected result is 0 when we call foo.sum passing in 0, right? So if we add 0, if we sum 0, it's going to sum to 0. We'll come up with a few of these things. So if we sum 1, what if we sum 0 and 1, right? That should equal 1. If we do 1 and minus 1, the sum should be 0. 1 and 2 and 3, the sum should be 6. Negative 1 and negative 1, sum should be, if I remember math correctly, negative 2. 10 and 21 should be 31, right? So we can do various things. That's good enough. So those are all the things that can go well. We haven't thought about what can go wrong. So I'm going to make a copy of this test. Call it some bad. And this one gets a little tricky, and I should have actually copied some code, but let's give a very simple version of this right now. So in Java, if something fails, we typically throw an exception. So if we call foo.sum passing in null, that should cause us a problem, right? Okay, and what it should do is it should throw in a legal argument exception. And we can do an assert equals on that. That the message is going to equal values cannot be null. And we're going to do that by calling getMessage. So when we call foo_sum, we expect it to throw in a legal argument exception, and we expect that to have a message called values cannot be null. If it doesn't throw the exception, we also need to do a fail. Okay. So now we have tested our program. Notice we haven't written a line of code inside of sum, but we've sorted out before we even start writing the code what it is that how that's going to behave, right? So we can successfully add all these up supposedly, and we've thought of the bad data is. So now we can go write our code. So first thing we want to do is say if the values equals null, throw new illegal argument exception. Values cannot be null. Oop. And for now, I'm just going to say return 0 so we can see some things fail too. And then I can go ahead and run the tests. And here we see that some bad passed, right? So this one was done correctly. We did it properly. But sum itself didn't work, right? When we went to sum 1, it failed. And that makes sense because we're always returning 0. Let's just see also if I made a mistake. Just add a space to the end of this string. And now run the tests again. And now they both fail. And it's telling us that its expected values cannot be null, but we got values cannot be null with a space. It's kind of hard to see spaces, which sucks, but yeah, that's the way life is. So now all we have to do simply is implement this. And run our tests again. And if I've done everything correctly, they both pass. We're done. Yay. But we haven't done one thing that we should have done last time, that we learned from last time. Before we started coding this, we should have written this, right? So we should say what this is actually for. Sum an array of ints. Values to sum, return the total of all the values in the array. And what we're missing is throws, illegal argument exception, if values is null. Right? So now somebody knows what's going on with the function, what the parameter is, that it can't be null, and what the expected return value is. So they can read that. So we've got this for our documentation, and we've got this essentially for a specification. So this tells us what the function is supposed to do, how it's supposed to behave. And in reality, this is going to be like the shortest stream ever. In reality, this is unit testing. I mean, that's really all there is to it. And this is what we call test-driven development. So we come up with our functions, we figure out how to test them, we document it, and then we test it. Sorry, then we run write the code to pass the tests. And when the tests pass, presumably we're done. This assumes that we did a good job of our testing. And there's a couple of tools. We'll get into tools at some point in time later. One of them would be code coverage, which would tell you what part of your code is actually running. So we'd actually be able to see if all of our code actually executed with these tests. This code is so simple, I can guarantee that it does work. This also drives how we design things. So if we were to do something like void do something, right? And in here we're going to read from the user, do a calculation, print to the screen. So we're going to read something in from a user, we're going to do some sort of calculation on that, and we're going to print the result of that calculation to the screen. That's really hard to test. Like, how do I test that? First off, it's not automated because the user actually has to enter in a value. Then we have to do the calculation, which has nothing to do with reading the value, and then we have to print the result. Same thing, nothing to do with it. So instead, what I'm going to do is I'm going to write 3 functions. And we're going to get a little closer. It's not going to quite work yet, but we'll get there. So now I've broken up my function into 3 different things. I get the value from the user, I calculate the result, and I display it. So now I can easily test the calculate, just like I did with sum. And I can't really test display at the moment. So there's a couple of choices I have with that. So what I could do is I could change this to change this to be like get display message, where I give it the result and it returns the string that would be printed out, and then we print that out ourselves. So I've got a way to test this now, right? So given this result that I pass in, just like I'm doing with these here, right? I just do foo.getResult kind of thing, or get display message. I could pass in whatever result I want and do the appropriate thing and check for null and all that kind of stuff, or a negative number or whatever. I mean, calculate, same thing as sum, easy to test. This get value from the user, that sucks. So what I need to do somehow is abstract this. And it's probably something like this, where I give it an input stream. So rather than reading from standard in, I'm saying read from this input stream. And then I can give it a file for my input stream, and I can just say, okay, read the next value from the file. Or I can give it a character input stream or a string input stream or whatever, which will let me hard code a value in my test to say, read from this string as if it were a stream. And then that's like the user typing in, but I don't actually have to have the user type in. So by trying to figure out how to test it, I've actually made my code much better. It's broken up into smaller functions, methods, that work independently, as well as I've managed to abstract reading from the user to reading from a stream. So rather than read directly from the keyboard, it can be anything. I'm not displaying a message, I'm just getting the message to display, right? All of these things become much simpler. Now this do something now becomes get value, something like this. And I don't have to do something, because that's not a testable function, because it takes no parameters and returns nothing. All I can test for is side effects. I can test what gets printed out to the screen. It's not fun, but you can actually do that. But ignoring that, we don't need to test do something, because we know all the component parts work, and that's just a straight through function. So we're good there. So by trying to make things testable, we break them out into smaller functions. Each function has a well-defined value. You want a well-defined value because you want your tests to be pretty simple. Okay? If your tests are simple, it's easy to get things right. That's it. That's unit testing in a nutshell. Any questions? Cool. It hopefully is straightforward. Awesome. So hopefully this one records, and we can put it up. For those of you who are in the diploma and wanting the C1, it's still coming. So I'll get that up, video up sometime this week. Alrighty. I'll talk to you guys later. Have fun.